Okay. Yeah. Hi, I am back. Last lesson we were talking about four states of matter. Okay. Uh, Solid, liquid, gas, and plasma. So let's continue talking about physical properties of matter. Okay. So if we are gonna talk about a physical property is a characteristic of matter that can be observed and measured without changing the simple composition. So this is very important because we can talk about this with an example. Okay, I'm gonna show you. Let's go back to the periodic table book, and here we have gold, for example. Okay, so look at this. Look, that piece of gold that we have on the left side. If you look very well the figure, you can see that gold has a yellow color. Yeah, and of course it's a yellow color, and it's bright. It's bright. And the physical property that we have here, for example, is the color yellow. Okay, so if I pick um, just a little bit of that piece of gold, a little piece of gold, we will have the same properties that the big part of gold, right? Okay, so also these physical properties describe to pure substances, okay? Because substances have uniform and unchanging composition. They also have consistent and unchanging physical properties. So for the example, the gold, okay? The same property that we have on a big piece of gold, we will have it on the little piece of gold, okay? So density, the density of the big, look at this, the density of the big piece of gold will be the same density of a little piece of gold, okay? So that is a important physical property. Color, okay, color, gold will be yellow everywhere, on China, here, or I don't know, Africa, will be the same color. Other, hardness, the melting point, and the boiling point of each element, for example, okay? And it's a physical property. Good. So we can read this chart over here, this table. For example, we have on the left columns substances, and we're going to talk about color, the state of that substances, of that substance, sorry, at 25 degrees, the melting point, the boiling point, and its density. So oxygen, okay, the color of, well, is colorless, okay. The state at 25 Celsius degrees is gas. The melting point is minus 219. The boiling point is minus 183. And density, of course, is a gas, will be a very low density. Okay, 0.0013. And mercury has a silver color, okay? We can use our periodic table book and we'll got, okay, mercury, there it is, okay? Look, the liquid form of pure mercury, okay? It has a silver color, right? Okay, it's liquid, and for example, the melting point is minus 39 Celsius degrees, and the boiling point is 357. Oh, this is very important, because if we want to talk about density is 13.5. Yeah, it's 13 times bigger than density of the water. So look at this, okay? Yeah, the mercury has a huge density compared to the water. Water is colorless, it's liquid. A melting point will be 0, and boiling point will be 100, okay? And sodium chloride is white, solid, has a melting point of 800 Celsius degrees, and the boiling point 1,400 Celsius degrees, okay? All of these properties or characteristics we have for each substance is a physical property, okay? Okay, if we talk about physical property, we can divide it on two different physical properties: the extensive property and the intensive property. So extensive property are dependent on the amount of substance present. So for example, mass, length, volume, yeah, all of them are dependent on the amount of substance. Of course, you have a big piece of gold, for example, you will have a big mass. Okay, and a big mass, you will have a big volume, for example. Okay, so of course, it depends on the amount of substance. An intensive property is independent on the amount of substance. So for example, density, okay, and this is very important. Density doesn't change if I have the entire ingot of gold or if I have the half ingot of gold, for example, okay? Density will not change. And we have temperature, okay? Temperature is independent on the amount of substance. Other essence, okay, they are independent too. Okay? Very good. So every substance has its own unique set of physical and chemical properties. For example, copper, it can be shaped into different forms, such as the wires on our circuit boards, for example. But the fact copper turns from reddish to green when reacting with oxygen, okay? And we can see that, let me see, I'm gonna show you. One moment, I will show you a picture of this characteristic. Okay, I will share with you the screen. Okay, there it is. Let me see. Oh, we have here. So copper wires from the left and the copper roof on the right. Okay. Yeah, but copper can react with oxygen, and the difference will be the change in color. Okay. That will be a chemical reaction, right? Okay. And we're going to talk about chemical reactions later. Okay, going back. So let me see if I can. Okay, go back to the. Okay, there it is. Okay. So the properties of copper might vary depending on the conditions under which they are observed. The particular form or state introduces or add another physical property to its characteristics. It is important to state the specific conditions, such as temperature and pressure, for example. Physical and chemical properties depend on these conditions. So remember the example that we saw for mercury, okay? Mercury at a temperature of 20 Celsius degrees has a liquid form, okay? Very good. Okay. So for copper, physical properties of the left column, okay, is reddish, brown, shiny, easily shaped into sheets, is malleable, and drawn into wires, for example, is ductile. Is a good conductor of heat and electricity, okay? Density, melting point, boiling point, all of these will be physical properties. But on chemical properties, column from the right, okay, forms green copper carbonate compound when in contact with air, for example, okay? As you saw on the picture that I show you, reacts with nitric acid and sulfuric acid, forming new substances. One type of compound forms a deep blue solution with contact with ammonia, for example. Okay? So these are chemical properties to the copper, for example. Okay, very good. And if we talk about the water, okay, water at the standard temperature and pressure, that is 20 Celsius degrees, and 1 atmosphere, atmosphere will be the unit that we are going to use to the pressure, atmospheric pressure, okay, is the pressure that the atmosphere does on the Earth surface. Okay, that is a atmospheric pressure. Okay, so water under these conditions is liquid. Okay, that is a physical property. Is not chemically reactive. Okay, that is a chemical property. At temperatures greater than 100 Celsius degrees, water is gas. Oh, that is a physical property. And react with many different substances. Oh, it can be a chemical property. Below 0 Celsius degrees, water is a solid. Oh, that's a physical property with a density about 0.92. Okay, that will be another physical property. And fact that icebergs float on the ocean. Okay, so that is like a tiny Titanic, yeah, the iceberg. Okay, excellent. So now we have a little practice over here. Okay, classify the following properties as either chemical or physical by putting a check in the appropriate column. Okay, so we have all of these properties, physical, chemical, and we have to classify with a check. Okay, so let's do this. Okay, so let's check. So blue color, yeah, blue color is a physical property. So check. Density will be a physical property too. Check. Flammability, okay, flammability, okay, is a chemical property. So check over here. Solubility, okay, solubility is a physical property. Okay, check. Because why? Okay, why? Solubility is a physical property. Can be a question. Okay, solubility depends on the shape of the molecule that we are combining. Okay? So, for example, oil and water doesn't mix each other. Okay, you cannot mix. You cannot do a mixture between oil and water. So that will be a physical property. Okay, because oil molecules are totally different with respect to the water molecule. Okay, so the molecules form is very important to classify this particular property of the solubility. Okay, reacts with acid. Okay, reacts with acid. This will be a chemical property. Okay, so check over here. Supports combustion. Okay, supports combustion will be a chemical property. Okay, check over here. Okay. Volume is a physical property. Melting point, physical property. Hardness, physical property. Boiling point, no, is react with water. Okay, react with water will be a chemical property. Boiling point, that, okay, physical property. Conductivity, conductivity is a physical property. And neutralize a base is a chemical property. Okay, very good, excellent. So, continue about changes in matter. Okay, imagine crumpling aluminum foil from a smooth, flat, mirror-like sheet to a round, compact ball. Okay, so imagine that. The substance looks very different, but its composition is unchanged. It is still aluminum. Okay, a change such as this, for example, which alters a substance without changing its composition, is a physical change. Okay. So, phase change. As with other physical properties, the state of matter depends on the temperature and pressure of the surroundings. As temperature and pressure change, most substances undergo and change from one state or phase to another. Okay, so a phase change is a transition of matter from one state to another. Okay, so solid, liquid, and gas. If I aggregate heat to a particular state, for example, aggregate heat to a solid, I will melt it. Okay, so that's the process name. Melting is go from solid to liquid. Vaporization is going from liquid to gas. And sublimation is going from solid to gas without pass the liquid state. Okay, that's very important. Okay, so this little guy here, here, and here, those are changing processes or a phase change that, of course, needs energy to do that. But if I take energy from the state, I will do condensation, freezing, or deposition. Yeah, of course. The name depends on going from one state to another. So, for example, condensation is when you go from gas to liquid, and freezing is going from liquid to solid. Okay. Deposition will be from gas directly to a solid, for example. Okay. Excellent. Chemical changes, okay, is a process that involves one or more substances changing into new substances. That is called a chemical change. Okay. Commonly referred to as a chemical reaction. Okay. Chemical reaction are very important for us because we can change an element, a compound, to another. Okay. New substances formed in the reaction have different compositions and different properties from the substances present before the reaction occurred. So for example, let me see. For example, I can share my screen. Okay, so for example, we have here the electrolysis of water. Okay, so electrolysis of water can be a chemical reaction. Well, actually, we are electrifying the water, okay, to form hydrogen atoms and oxygen atoms from a particular origin. Yeah, water molecules, okay? So electrolysis of water produces hydrogen on the right, okay, and oxygen gas on the left, okay? If you can see the picture that we have here. Okay, so let me see this. Okay, if we have water, electrical energy, and the products will be hydrogen and oxygen. Okay, the final products will be hydrogen and oxygen, but the amount of hydrogen will be double if we compare to the amount of oxygen at the end of the reaction. Okay, and we can see in this table physical or chemical changes of some common processes. Okay, like rusting of iron. Okay, that is a chemical change because, okay, shiny bright metal changes to reddish brown rust. Boiling of water, that is a physical change. Okay, and we can see a liquid that changed to vapor. Burning of sulfur in air, that will be a chemical change. Yellow, solid sulfur changed to gases. Okay, boiling an egg is a chemical change. Combustion of gasoline will be a chemical change. Digestion of food, also a chemical change because food changed to a liquid nutrients and partially solid wastes. Sawing of wood, that will be a physical, okay? Sawing of wood will be a physical because smaller pieces of wood and sawdust are made from a larger piece of wood, okay? Burning of wood, for example, that will be a chemical change. And the last one, heating of glass, that will be a physical change, okay? That will be the table or chart that I got here. Let me see, okay, another physical change. Sawing wood produces a physical change. And this one, okay, look at this. Is the copper. Before heating, the wire is 100% copper. And the next picture, copper and oxygen from the air combine chemically when the wire is heated. And then after heating, the wire is black, okay, copper oxide, that is almost 80% copper and 20% oxygen, okay, and that will be a chemical change. Okay, perfect. So we're gonna finish this activity with a practice, okay? Classify the following as being a physical or chemical change. So let's do this. Okay. Good. So sodium hydroxide dissolves in water. Okay, that will be a physical change because says dissolves in water. Physical change. If the sentences says dissolves. A pellet of sodium is sliced in two. Okay, that is a physical change. Water is heated and changed into steam. Okay, hey, look at this. It's a physical change because water before heated is water and then converted to steam and continues being a water molecule. Okay, so it's physical. Potassium chloride decomposes to form solid potassium and oxygen gas. Okay, of course, it's a chemical change. We are converting potassium chloride into a potassium solid and oxygen gas. Milk sours, okay, that will be a chemical change because milk is converting to another thing, okay? Pancakes cooking on a griddle, okay, it's a chemical change because you are cooking. Water is absorbed by the paper towel, okay, that will be a physical change. Grass growing in a lawn, okay, that will be a chemical change. Crushing an aluminum can, that is a physical change, of course, because aluminum continues being an aluminum. Food is digested in the stomach, okay, that will be a chemical change. Okay, very good. So thanks. Next time we are going to talk about elements and compounds on the periodic table. So see you next time.